Okay. Unit 7 review. Simplify the expressions, so we put in the operators. You can't go wrong with the 3 lines, okay? So your number base, so you got a 2 times an x times a 7. Another x means I plus where I put the first one. Okay, so 2, we got a 1, 1 times 3 is 3. X, there's 2 x's because we put a plus sign. First one we take 5 times 3, that's 15. And the other one, 7 times 2 is 14, and then 15 plus 14 is 29. That's a big power, but it's just to an x, so we don't have to really simplify. 7 to the 1, 1 times 2 is 2. Okay, what's this guy, a switch or a stay? Well, if the exponent's positive, he stays on the side he's on. X to the 29th power, that's a stay. Then the 7 to the 2nd, that's a stay. So they all stay. Now these are the 2 we need to simplify. So 2 to the 3rd is 2 times 2 times 2, that's 8. 7 to the 2nd, that's 7 times 7, that's going to be 49. And then times x to the 29th power. Okay, remember the times till you get to the letter. 8 times 49 is 392. So there's your simplified expression. 392 times x to the 29th power. Okay, number 2. 4 to the 3rd, 4 to the 2nd, 4 to the 5th. So you got a 4. Now at the bottom you got a 4 times 4, which means you will just add the powers on your 4. Now I know 4 is not a variable, but we treat it the same way. So you have a 3, and on bottom a 2 and a 5. I don't need to add these because, or I don't need to multiply because there's not any parentheses. So 2 plus 5 is 7. Now, you got to cancel because you got base 4s on top and bottom. So you get rid of the one that's smaller, and then you take 3 away from 7. Well, that's a 4. So 4 ends up being to the 4th power. Now, it's positive, so that's a stay. And then I can definitely simplify that. 4 to the 4th, you can do the caret key. That's 256. Put the 1 over it. Okay, you need a 1 on top. Everything, if the whole thing ends up on bottom, you really need that 1 on top of it. Okay, number 3, if you have 2 fractions, no problem. You just combine it into 1. So you got a 3 times an x to the 3rd, then a 7th. And on bottom you got a 4 times an x to the 10th, and then a b. So we have 3 times x on top. And on bottom we have 4 times x times b. Okay, so I will be canceling the x's once I figure out their exponents. So 3 to the 1, it's just a 1. X here, 3 times 7 is 21, 21st power. Then 4 to the 1, but that ain't in parentheses, so don't take 1 times 10, buddy. Okay, so 1, x to the 10th, not in parentheses, and then b a 1, 1 times 7. Okay. Now, you know we can cross out x's, so you cross out the smaller one and you minus 10. 21 minus 10 is 11. Okay. Once you put 11, you cross out the 21 and the 10. That's gone. Okay, so is that a stay or switch? That's a stay. X, that's a stay. On the bottom, that's a stay. And then the b to the 7th, that's a stay. Okay, so 3 to the 1st is 3. Then the x can't be simplified. 4 to the 1st is 4, because we can simplify these two. And then b to the 7th. Don't do anything with the 3 and the 4. They're on there. 3 divided by 4 is a decimal. You don't want to put that. Okay, number 4. So underline the expression. So you got a times, a power, times a power, and a power, and a power. So you have 3 times x times y. Another x means I add to the first one. So let's talk 3. Base 3 to the 1. 1 times 3 is 3. x. Negative 2 times 3 is negative 6. There's got to be another one with a 5. So that's a negative 6 plus 5 is negative 1. Then y. 2 times 3 is 6. Okay. So with that being said, we're ready for, we don't cross anything out. We don't have anything on bottom. That's a stay. ST. If I put ST, that means it stays. That's a negative. That's a switch. So the X switches to the bottom, and when you switch it, it now makes a positive 1. That's the point of switching it. Okay, that stays on top. So 3 to the third, 27. So this is 27 times y to the sixth, and the bottom you have x to the first. Okay, there's your answer. Okay, a little scientific notation. Now don't overthink this. You don't make the 3 lines on scientific notation. That's not how you do it, because this is just one number, this is just one number. So you're going to take your 5 times your 3.4. You're going to break up, it's all times, so you break it up, so you're timesing the standard numbers. Then you're going to put your powers, so 10 to the 5th times 10 to the 3rd. So you just times the 5 and the 3.4. 17. If you got 17, you need to put a decimal right there. You need to have a decimal. Then on the base 10s, multiplication, you add them. 5 plus 3 is 8. Okay. Now, that's times, but the decimal has to be behind the 1, so I need to move it 1 to the left, so it's 1.7. Then I add 1 to the power. Okay. So 1.7 times 10, and now 8 plus 1 is 9. Okay. This is the same concept. Instead of the timesing, though, you're dividing. So break it up, so it's 4.5 divided by 9, and then 10 to the 3rd divided by 10 to the negative 7th. Okay. So 4.5 divided by 9, 0.5, times, cancel the negative 7, but when you minus, it's minus negative 7. And then that's the same as 3 plus 7, which is 10. So 10 to the 10th. Now you really want to circle that answer. Now that you're like, oh yeah, decimal's behind the first digit. 0 don't count, okay? It's got to be the first non-zero digit. So it has to be behind that 5. So I move it once. You can put a 0.0 there. And you moved it once to the right, so now it's minus. So 5.0, now the decimal's right, it's after the first non-digit, non-zero, then 10 minus 1 is 9. Okay, graphing. I'm going to just shotgun this, okay? So power of x, that's a times and a power, so that means we're going to do the input. It's not a line, you don't do m and b, totally different function. Your best bet for survival on the test is to make the input-output table integers 2 through negative 2. So 3 times, parentheses, 1/4 to the second power, so 3 over 16. That's less than 1 whole. 3/4. Now, that's 1, but times 3 would give you 3. Okay. Anything that's 0 is 1, but when there's a multiplier of 3, that's 3. Then 12, and then negative 2, so I got 48. Okay, you don't need to write this down, but here's why. Because if you look at the base and the exponent, if I made you do this along, which I'm not going to, I wouldn't have shown you how to do it on a calculator. If I do a 2, 1, 0, negative 1, negative 2, 1 times itself is 1. 4 times 4 is 16. Okay, but then times 3 takes you to 3 over 16. That'd be 1/4, but times 3 takes you to 3/4. That's a 1, but times 3 is 3. Now negative, you could switch the places to make it positive, and it'd be 4 to the 1, 4 over 1, which is 4. Switch places to make the exponent positive, because you're switching the positions. 4 times 4 is 16, 1 times 1 is 1, but there's no point in having. But then 4 times that 3 is 12, and then 48. So you see why that works the way it does. So we have to get to 48. So on the X, we're still going by ones, but on the Y, 5, 10, 15, 20, 25, 30, 35, 45. 45 is not enough, so go by tens. Okay, all right, so start here because that's where you got your most extreme, 48. Negative 1, 12. 0, 3, and all that happens are those last two is you get just close to the middle, okay? Because those are smaller, they're less than one whole. All right, next one. Caret 2, 1, 0, negative 1, negative 2. So we're going to take 1/4 times 4, caret 2 is 4. Click the up key. Got 1. This next one's 1/4. You can tell because it'd be 1/4 times 1, because anything to the 0 is 1. If you don't like that, just hit second PRB equals 1/16. Now, to get back to the screen, you click up, and then up till you get back to where you were. If you don't like that, 1 over 64. 1/64 is just a teeny. The bigger the bottom, that's the tinier it is. So X, 0, 1, 2. Okay, so then we can easily make it by ones. Okay, so 2, 4, 1, 1, 0, 1/4. That's just, all that does is just get closer and closer to 0. Okay, level it out against the line. Okay, these are quick ones. You don't even need to use a calculator. Right, this is a radical, okay? The bottom tells you what the radical is. It's a cube grid. And then inside you just put your 125x to the 1 power. That's all you have to do. Now, it's in radical. Now you need to write it so it has a fraction exponent. Rational exponent means a fraction exponent. So you put x to the second, make it a fraction, you put 3. And number 12, a family buys a car for $20,000. The car, the value decreases by 20% each year. Each year means per year. It means the same thing. Okay, how much will the car, so if you want to put per next to each, same thing. How much will the car be worth in 6 years? So again, dollars in years. So years is X, dollars is Y. So per, dollars per year. Problem is we don't have it, that's not $20 per year, it's 20% per year. So percent decrease is minus 20%. Well, the percent means you have an exponent function, expo. So you're going to times by the same thing instead of adding it. So we take 100% and subtract 20%, and that's 80%. So 0.80 is the decay factor. Because you need a factor. If you know it's an exponent and you need something you're going to multiply by. Just a 20 doesn't do it. Okay. So years is X, dollars is Y, so 0, 1, 2. So we put 20,000 at the beginning, but then we're multiplying, not adding. We're multiplying by 0.80. $16,000 after year 1. $12,800 after year 2. That's good enough. We got to find 6 years, question mark. So if we were multiplying, we don't make the line, okay? That ymx plus b stuff's out. So we make a new function, which is a times b to the x power equals y. So a, you got 20,000. And what did you start timesing by? You started timesing by 0.80. Now x we know is 6 equals y. So I just plug that expression in on my calculator. 20,000 times 0.80 caret 6. 5,243, if you want to put that, if you put 42 on it, or you could put 88, well, you don't, yeah, it's money, so if you want to put the 88 cents, that's fine, but I'm not going to dock you. So that's the one problem where you have to write your own equation with the table. This problem, we do not need a table because a compound interest is on the board, okay? You don't need to memorize it. I'll either have it on the board on the test or I will write it on your paper, okay? Like on the problem it's on. $2,000 is deposited in an account paying 2.5% interest compounded quarterly. What's the account balance be after 12 years? So this is the formula. 1 plus r divided by n. You don't need to memorize this. I will have it. Okay, so you don't need, the equation is known, okay? So you're finding what A is, but now you need to know what P is. That's your money amount. That's $2,000. R, that's your percentage as a decimal. So you put 2.5%, but you always got to move the decimal left twice. So 0.025 is going to be our R value. And I flat out told you it's quarterly, so it's 4. And then T is the years, which is 12. So we just put them into the equation. So P is 2,000 times 1 plus the R 0.025. The N is 4. Then N times T, so 4 times 12. You're going to use your calculator, but 4 times 12, you need to figure that out. Because when you do your power, you just want the single. Okay, calculator time. And it does the order of operations correctly and everything. Caret 48. $2,697.20 if you want to get specific, but you can just roll with the whole number. Okay, last problem. This might be on the test, it might not be. I keep saying that. Scientific notation story problem. Human body normally produces about 2 times 10 to the 6 red blood cells per second. How many red blood cells can be produced in 5 minutes? Okay, so you take that scientific notation number, and it says per second. That means you times it by the number of seconds. Now it's not 5 because that's minutes. Well, you just take your 5 times 60, and that's 30. Or no, 300, my bad. Okay. Then I do it like I did in a problem earlier in the packet. You take 2 times 300, and then 10 to the 6. Now 2 times 300 is a whole number, 600, so you put a decimal at the end, and then 10 to the 6. But if it's really supposed to be in scientific notation, okay, it has to go behind the first digit, the 6. Okay, so 1, 2, so 6.0. We moved it twice and we moved it left, so that's plus 2. So 6.0, and 6 plus 2 is 8. So 6.0 times 10 to the 8th power.